Hi, Paul Turley here for Pass, and in this edition of BI Pass Insights, I'm going to talk about large data. Paul, don't you mean big data? Well, big data is a data structure and storage architecture that is suited for large data sets, but that's not what I'm talking about. By large data, I just mean working with high volume data in BI solutions. Now, we've had BI architectures suited for working with large data volumes for quite some time, but they've been costly and cumbersome to use. Now, the folks at Yahoo built a 30 terabyte cube well over a decade ago using SQL Server analysis services. If you've attended a Microsoft conference event in the past year or so, you've probably seen Christian Wade from the product team demonstrate clicking and dragging to consume petabytes and trillion row data sets with Power BI. Now, most of us don't have trillion row data sets, but it's not uncommon to work with millions or billions of rows of analytic data in a data model. Now, the other day, a potential consulting client asked me if they could consume 100 gigabytes of data with Power BI. And my answer was simple: yes, but the right solution architecture is going to depend on a few things. Let's do some quick math. If I have a SQL Server database that is 100 gigabytes on disk, chances are that we have at least 10% page fragmentation, so we might have 90 gigabytes of compacted data to work with. Building a star schema on that transactional data, we're likely going to leave out half of our tables and columns. We'll omit things like binary objects, XML, JSON structures, maintenance columns, and large descriptive values that aren't really useful for analytic reporting. So, being conservative, let's say that we leave out half of the tables by volume, 45 gigabytes. We'll keep 2/3 of the column data, again, by volume, down to about 30 gigabytes. Now, depending on things like the sparsity, density, and duplicate values within columns, you can expect with Vertipack in-memory compression somewhere between 5x and 20x compression. Let's be really conservative and let's say that we get 5x compression. Now we're at 6 gigabytes, but a better case scenario might be 10x, 3 gigabytes, or 20x, which is 1.5 gigabytes. So again, being conservative, we're now down to 6 gigabytes of data. I'd like to show you one of my favorite new features in Power BI Desktop used in premium capacity. This is a feature called Incremental Refresh, and you can see here in Options and Settings, if I go to Preview Features, I enable it right here. Now, it's been in preview for a while and I found it to be a pretty solid feature, and I'm actually using it in production, but it'll be out of preview, of course, after it's tested thoroughly. Once that's on, I can define incremental refresh policies. Let's go to the query first. So for my larger, typically fact tables that have a lot of data in them, I want to be able to define these incremental refresh policies that will translate into partitioning my data and only refreshing the data that is new and leaving historical data in the model. Now, to do this, I start with defining two different parameters called range start and range end. They have to have these names and they have to be date time data types, even if you're just using dates. And I can set them to as narrow a band as I like, and then I'm going to filter each of my big queries using these date ranges. And that actually just loads up a smaller set of data in preview, so that the data sitting in desktop is much smaller than it might be in the service. Then I'm going to make sure that my query is based on a table or a database object, any of the data sources that work with real databases that support query folding, meaning that the M query actually gets translated into the native query language of the data source provider. So I'm just actually pointing to a view in this case. Don't use an inline SQL statement. If you need to build a T-SQL query, then write a view and store that in your database. And then I define a filter where I use those date range parameters. And they need to look like this: is after or equal to the date range start, and is before range end. Notice that when I right click on this step, I can view the native query. That tells me that the previous steps support and don't break query folding. And I can actually view the native query generated along with my filter predicates down here that are going to filter this data. If I have steps later on that break query folding, doesn't matter because they're based on that minimal set of data that comes back. Then here in my data model, I can go to this table and I can implement an incremental refresh policy. And this is where the magic happens. I'm saying I want to implement incremental refresh on this table, and I want to store up to 5 years of historical data. I can do this on as many date parts as I want. They can be days, months, quarters, years, etc. And I'm expecting data in the last month to have changed. And so go back and refresh 1 month at a time, but don't go back and rerun queries older than 1 month and up to the last 5 years. But when I deploy to the service, that's going to kick off a data refresh cycle and implement my incremental refresh policy, which is going to load up all of that historical data, build the partitions in my model, and all of that data will be available up in the service. How much data can I load? Well, keep in mind that a Power BI Pro license allows me to upload as much as 1 gigabyte of data. Incremental refresh is a premium feature, allows you to upload up to 10 gigabytes of data, but I can process up to 12 gigabytes of data. I want to actually minimize the PBIX file. So I may be uploading a few hundred megabytes of data, which will go pretty quickly. And then as soon as that refresh cycle kicks off, it's going to take a little while to load up all the historical data. And then on each of my scheduled refresh cycles, it's only going to process the data that's changed. And so now I can have up to 12 gigabytes of data available up in the service, keeping in mind that that's compressed data, and that can be a lot of data to support my enterprise analytic reporting needs. Thanks for watching. I'm Paul Turley for PASS, and thank you for watching the BI PASS Insights February 2019 edition. See you around.